Okay, while we get this going, my name is Nat Tylor. I am a product manager at Magnite, but here as an AI tinkerer, which is what I like to do on the side. I haven't been to an event in about a year, so I'm really glad to be back. This is my second time presenting, but to a much bigger crew. And without further ado, I'll kick it off. Looks like, oh my gosh. Hopefully that's sharing. Okay, so first I'm going to talk a little bit about DSPy, but first, joke or no joke? Joke, okay. Uh, so a prompt engineer, a data scientist, and a DSPy engineer walk into a bar and order an IPA. The prompt engineer spends 20 minutes giving complex instructions and eventually gets a beer. The data scientist whips out his laptop and trains a BERT model on the entire menu. And then the DSPy engineer says, here's my signature. The output I need is a beer. Let the optimizer figure it out. That's the punchline. You're supposed to laugh. Okay. So there we go. Like I said, I wanted to talk a little bit about my recent experience with DSPy because I just think it's cool. So here I am. I'm going to use this today for a demo task of classifying the sincerity of Quora questions. This is a data set that's available for free on Kaggle, so I thought it'd be cool. The goal is basically figure out whether it is seeking helpful answers or trolling. And so I'll walk you through just a brief DSPy program that I wrote to do this because I find the DSPy website very difficult to get into, and like sometimes you just need a quick example. So here we are. But first, like, why would you use DSPy? You might start with a prompt, something like this. You're an expert classifier. You need to do this classification task and respond with JSON. And you might get like some decent results. You do some vibe checks, and you're like, okay, this is working semi-good, but I have examples that aren't correct, and I need to fix it. So then your prompt grows, and like eventually you have this like ever-growing string of conditions that seem to be helping the model, and you're doing vibe checks, and you're like, maybe I'm making progress, maybe I'm not. And I don't know, if you're like me, you get frustrated by that, and you're like, this seems unsustainable. Like, how am I ever going to fix this? And so I think DSPy has a very cool approach to this problem. So I'm going to show you this brief program and then kind of expand on some pieces. So after you import DSPy, you need to configure it, give it a language model. It's backed by Light LLM, so you can use really anything. I've chosen Gemini here, it doesn't really matter. And then you get into the program. And simple DSPy programs are incredibly simple, which I think is like a great part of DSPy. It's not this really complex thing. It can be as simple as this line, which is saying, my inputs is a question text, which is a string. My output is is it sincere, which is a Boolean, and use the predict module, which is telling DSPy a certain prompting strategy to use. And then to do evaluations, I've loaded some training data, some evaluation data and some training data, which I'll show you in a minute. But you need to have a metric. And I also used to think metrics were really like sort of hard to understand. But like this metric is incredibly simple. It is literally just checking the example. So like your golden data set against the predicted outcome and giving it true if they match and false otherwise, and then DSPy knows to treat that as a 1 and a 0 and can do its evaluation. So you declare an evaluator. This is a list of examples. My metric is defined right there, and I want it to display progress. And then let's evaluate my base classifier, which is what I defined up here. So I'm going to run this. DSPy caches the language model call, so sometimes they run incredibly fast, like that just happened. But my base classifier really stinks. It got 2 out of 16 right. And so there's this nice, how do you get rid of this thing? This nice presentation of the table, which is helpful to see like, what did it get right? What did it get wrong? So I don't really want to go through any of these questions, but it only got 2 right. So then if you were not using DSPy, you might then like start to iterate on a prompt and add some more detail to the task and tell it some context and this and that. And you're getting that longer and longer string, which is encoding like both the instructions and the inputs and outputs and like how you want it to do it and the prompt structure. And it's hard. It's also difficult to like work with other people on. So instead, in DSPy land, you can just use an optimizer, or as they often call them, a teleprompter, which basically iterates over some of your examples and then evaluates again. So this is the most boring optimizer there is. It just picks a few examples, shoves them into the context, and compiles which then produces basically a new prompt, and you can then evaluate that again. So I already ran this cell, so let's look at the new output. So it bootstrapped 4 full traces with 5 examples, blah, 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 and the accuracy is up to 81%. So that's great. Like, we didn't do anything. All we did was give it some examples, and we're already at 81%, so that's pretty cool. And you might even stop there. Maybe 81% is good enough. But what you have now is this really composable program that you can do more things with. So as an example, there's other optimizers. So this bootstrap with random search is going to try a couple of different permutations of your examples to see if they drive better results. So let's run that. It tried the first round, it got 12, and the second round, it got 100% right. So it's going to pick the one that got 100 and then use that program and run it over my evaluation data set where it got 15 out of 16, 93%. That's great. Again, with one line of code, now we've done a whole another set of iterations. You might be now remembering that essay, Show Me the Effing Prompt, where you're like, well, I don't really like this because the program is writing my prompt, but I want to know what the prompt is. So DSPy is very inspectable. It has this nice inspect history thing, which will show you the prompt that it ran. What happened? Oh, yeah. So you can see it's compiled this pretty long prompt, but I like how simple the instructions are. It's just like, literally, here's your inputs, here's your outputs. Oh, this is the, let me run this again. That cell doesn't want to run. I don't know why. This is the output from the thing I'm about to show you, but it's added this reasoning. Okay, let's just look at what I was about to show you. You can also do, in addition to different optimizers, you can use different modules, and those are kind of the prompt strategy. So here I've implemented chain of thought, which basically adds a new key to our output of reasoning, which is known to kind of help the models along with figuring out good answers. So if you run that, it again, how did it do? Pretty terribly, actually, 50%. But it produced this long reasoning string, which again, for some classification tasks will really help your model or help the performance. So, and then you can go down here and see what it did. It added this thing about reasoning to the prompt structure, and then for every one, all the examples, it has the reasoning inserted. Where we go? These get quite long. Here you go. Here's some reasoning that it's using as examples to give to the model and insert into the context. Okay, I am almost done. I wanted to show 1 or 2 other things. One is that I started with this super simple sort of declaration of my program. You can also write that one line as this program, and I show you this to sort of illustrate that your program can be as complex or as simple as you want. So you can add as many steps in between here if you want to do intermediate things or you want to do multiple tasks within one task. It's like, again, you're just building a little program. You're not writing a prompt. It's nice. And then, yeah, I wish, oh, this cell's actually going to run now. Great. So you can use this to go back through your history. This also integrates really nicely with ML Flow. So if you have an ML Flow server running, you can send the traces over there and inspect them there, which can also be really nice. And then I just wanted to conclude with, it's great to start with some data. So in this case, I had a CSV that I downloaded from Kaggle, and I loaded up with the DSPy example function. So you can see right here, I'm declaring some examples. So you basically tell it, like, from my input data, you know, here's the question text, here's the output, and then you want to tell it that the inputs that it has are the question text. But if you don't have that, you don't have pre-labeled data, you can kind of get started by just sending just inputs through the model, use the outputs from like a powerful model as the training and evaluation set you want to use, and then you could build your own little like vibe-coded classification UI to put a human touch on it, whatever you want to do. But you don't really need labeled data. You can kind of like bootstrap your way there, which is great. And then the optimizers go on from there, and you can do like actual prompt optimization. There's one called MiPro, there's one called Simba, there's a brand new one called Gepa. Gepa's cool. It like evaluates the reasoning trace from the model to see kind of like what it explored, and then adds new stuff to your prompt to optimize. And so again, and you do all that without having to like muck around with long strings, and you can experiment very quickly. And it makes classification easy. And lots of other, they have a React module for doing agentic work with tools and things if you want to get into that. And that's it. So hopefully you can give DSPy a try. I will post this like on my blog, which you can find through my link if you want this little simple toy example. Yeah.